Hello everyone and welcome back. In this video, I'm going to go through examples of nested classes in Java. There are 4 different types of nested classes in Java, and I'm going to show you a demo of each one and how you can access members in both the nested class and in the enclosing class. I'm going to do this in IntelliJ IDEA for my IDE. I'm not going to do anything that's specific to IntelliJ in this video, so if you want to use a different IDE or you want to use a text editor and command line or whatever flavor you like to use for your development, go ahead. The fact that I'm using IntelliJ is completely irrelevant for this demo in this video. I'm going to call my new project Nested Class Fun. It may not be fun, it's actually going to be a little crazy. Nested classes can get kind of complex kind of fast, but I'll do my best to describe each of the 4 types and give you an example of some running code that you can use perhaps to apply to your own Java code that you're writing. All right, so I'm going to need a main, and I'm going to put my main method in a file called class tester. It's going to test a bunch of classes. We are in fact doing nested classes in this video, so we know we're going to test some classes out. So here's my main, and I'm going to take some quick notes about nested classes here, and then we're going to start coding up some nested classes. So what is a nested class? Well, you probably have a sense of what a nested class is because you've heard the word nested before, right? You know about nested if statements. It's an if statement defined inside the body of another if statement. Or maybe you've heard of nested loops, like, for example, a nested for loop is a for loop that is defined inside the body of another for loop. Okay, so in that case, we have 2 for loops. And here, let's do it real quick. So you've probably seen this before. Actually, I can do this even faster with the shortcuts. All right, so here is a nested for loop, right? This is our outer for loop or our enclosing for loop, and this is our inner for loop or our nested for loop, right? This for loop is defined inside the body of this for loop. Okay, great. Goodbye, nested for loop. Back to nested classes. So a nested class is just a class that's defined inside the body of another class. So we've got some new terminology to introduce here. Let's start with outer class, and I'll put an AKA here, also known as an enclosing class. So this is a class that is not nested, but maybe has a nested class as a member. Okay, so an outer class would be the classes we've been working with so far, right? They haven't had anything nested inside them, but they could, right? They're outer classes. So an outer class can be public or package private for its access modifier. It can't be protected and it can't be private. If it's outer, it's either public or package private. And recall that if you have a public type like a public class and it's an outer class we're learning now, it has to be in a Java file that has the same name, right? So if I were to rename this class tester 2, right, my code is going to break because class tester 2 is public, and as it says here, it needs to be declared in a file that matches the name class tester2.java. All right, just a little bit of review right there. And kind of fun now that we're learning about the fact that class tester is an outer class, right? Okay, great. So next, I said there are 4 types of nested classes. Let's go through them. First, we have a static nested class. Probably the most straightforward to use. We'll do this one first. If we can have a static nested class, it makes sense that we can have a non-static nested class. And that's kind of a mouthful, right? Non-static nested class. So this is also known as an inner class. So if you see inner class, think non-static, which means it's associated with an instance of the enclosing class. All right, number 3, we can have a local inner class, and I'm gonna expand this out to kind of its full form. So An inner class, we know, is a non-static nested class. And when we see the word local, what we should think of is a local variable, right? A local variable is a variable that's defined inside of a method, right? It has local scope. So we want to use that same way of thinking to think about a local inner class. So a local inner class is a non-static nested class that's like a local variable defined inside a method. Okay, and now our last one, we can have an anonymous class. An anonymous class, I won't expand it super far. I'll just say is a local inner class without a name, hence the anonymous part. Okay, so fully expanded, this would be a non-static nested class defined inside a method without a name. If your head's spinning a little bit, it's okay, I don't blame you. This kind of got crazy really fast here. But don't worry, we're going to go through an example of each one. And I'm going to name each of these classes, except for the anonymous class, it has no name, corresponding to what it represents. So our code should read fairly easily about what it's doing, or it should read fairly well and describe what it's doing. All right, so let's get started. We need a new Java class. So let's start with an outer class. All right, so outer class is going to have some fields. And as the name implies, this is an outer class. So let's do a static and a non-static field. So static int, static field. I'll initialize this to 0. So this is static. So this is class level. And what that means is there's one, I don't want this to be like that. There's one static field variable shared amongst all instances of outer class. Okay? One static field shared amongst all instances of outer class. Okay? So each object of type outer class doesn't get its own static field. It has access to one common static field. Okay, and then let's do int instance field. So as the name implies here, this is non-static, this is instance level. And what does this mean? Each instance of outer class, so each outer class object, gets its own instance field. All right. So far, so good. Let's make a constructor. Here, I'm going to just initialize my instance field. I don't really care what value I use here. And I'm going to be really explicit about where our code is executing and when. So I'm going to say things like, hello from outer class constructor. All right, great. So let's exercise our outer class and just do a little review of static versus non-static. It's always good to understand that. All right, so let's head over to class tester. And we're going to access the static field of outer class. Because it's static, we do not need an object or an instance of outer class in order to access it. We're just going to use the type name, outer class. So let's print out outer class dot, okay, and note, because I have the name of a type, I can only access static members of the class. I can't access any instance level members of the class. Like, for example, I don't see toString, right, which we know we inherit from object. I don't do that here because toString is non-static. All right, so I'm going to print out static field. And I'm going to make, here, let's label. Let's be really explicit. Let's label this. So static field, non-static field. Okay, and every time I say non-static, I mean instance level. Every time I say static, I mean class level. And let's make an outer class object. Okay, in order to create an outer class object, I've got to use the new keyword. This is going to invoke the constructor, right? The constructor we just made. And note that this is really important. By convention, I'm going to use lower camel case for my identifiers, right? So this is an identifier for a reference to an outer class. I can look at this right here and know that this is a reference to an object because it's lowercase o. I can look at this right here and know that this is the name of a type because it's Pascal case, right? Capital O, right? This is a good convention to follow, right? For example, here's Pascal case for my class tester class. I can look at it and know this is not an object, this is the name of a type. But I look at main here and this is lowercase, right? This is this is lower camel case. And I know that this is an identifier, right? This is an identifier for a method or a reference or a variable. But in context, I know that main is actually an identifier for a method, right? But if this was capital M main, then that would imply that that's a type, right? So always follow convention. It makes reading your code, and for others reading your code, makes it much easier. Okay, great. So now I have an object, which means I can access instance field. So let's do instance field. Outer class dot, and if you see here, I can access instance field. Okay, I can also access static field even with an instance, okay? Just to show you that. I can also access static field with an instance of the class, okay? This is one variable that's being shared by all objects. All right, let's come back to that in a second. All right, instance field. Everything looks good. It's time to run this. Okay, so recall I initialized static field to 0. Okay, hello from outer class constructor. That's from line 19 in class tester. And then I initialized instance field in my constructor to 1, and there's that 1 being printed out here. All right, let's do this. Yeah, let's play with static field to prove there's only one variable shared amongst multiple, I'm going to say multiple, I'm going to say all outer class objects. All right, so I'm going to make another outer class object, call this outer class 2. Okay, so I'm going to do outer class dot static field plus plus. I'm going to print it out. And then I'm going to do the same thing, but from outer class 2. All right, so recall I initialized static field to 0. Now I run this. Line 27, I'm going to add 1 to static field, print it out. Now static field is 1. I did that using outer class. Now I'm going to add 1 to static field again, this time using outer class 2, and now it's 2. I could even do this. I don't even need an object. I don't need an instance of outer class in order to access or update static field. It's static. So I'm going to do this without an object. I'm going to do outer class.static field plus plus, and then I'm going to print this out one more time, and I'm going to print this out. I can use anything. I can use outer class 2, or the type outer class. I'll just do this object. It doesn't matter. This is the same variable. I'm just using different ways to access it. All right, so it should be 3, and it is, okay? So there's some nice evidence here to help convince you that static field, because it's static, there's only one variable, and it's shared amongst all of the different objects of type outer class. All right, that's important. Okay, I'm going to comment this out. I'll leave outer class 2. Now, let's say I do outer class 2 dot instance field plus plus, and I print out outer class dot instance field. And let's do this with outer class 2, and you'll see that these are two different instances. Okay, so they have two different copies. They have their own copy of their non-static fields. All right, so I'm gonna make a change to each one, okay? This is a different variable than this one. This one belongs to the outer class object, this belongs to the outer class 2 object, and then I'm gonna print out both of them. Okay, so if they refer to the same variable, right, then this update should add 1 to 1 to make it 2. This should add 1 to 2 and make it 3, but it doesn't. Okay? What I get here is output from two different variables that are being updated. Okay, this one's being updated by outer class, this one's being updated by outer class 2. These are two different variables in memory. So I print them out here, and they've both been updated by 1, starting at 1. All right, let's do this. Let's do outer class 2.instance field plus assign, say 5. Just so you can see that these two numbers are going to be different here because they're two different variables. Okay, so in this case, outer class instance field is 1 plus 1 equals 2. There's our 2. Here, outer class instance field is 1 plus 5 equals 6. It's not 2 plus 5 because this instance field is different from this instance field. Okay, I think you get the point. Let's comment this out. And I think we can get rid of outer class 2 now. All right, nice little refresher on static versus non-static. All right, so it is time now to move on to our first nested class. So this is going to be a static nested class. So I'm going to nest a static nested class inside of outer class. So this is number 1, static nested class. So I'm going to call this class static nested class, just to be really explicit. All right, so here I am. Note that this is defined inside of the body of outer class. And I'm going to take a little bit of notes about static nested classes. All right, so nested classes in general are members of the enclosing class. Okay, and a member could be like a field or a constructor or a method, or now we know a nested class. So static nested classes specifically, like what we're working in right now. So static nested classes can access static fields. I'm going to say static members, just to be all-inclusive here. Static members of the enclosing class. Okay, they can't access non-static members, like they can't access instance field because this has no this reference to an instance, but they can access static fields like this one. So I'm just going to write that really quick. So static nested classes are not associated with an instance of the enclosing class. So know this reference for static nested class and know this reference for outer class. It's static, okay? Static and this do not go together. All right, so let's make a constructor really quick. Just make a default constructor, and we're just going to do like I did before and say hello from static nested class constructor. And let's see what we can access. So from here, I can access static field. From here, I cannot access instance field, right? I don't have this reference. I don't have an instance of outer class. All right, so I'm just gonna print out static field. And I'm gonna head back over to class tester, and I'm going to make an instance of our static nested class. So if I just try to do static nested class, note it's going to insert outer class dot in front of static nested class because it's a member of outer class. So whenever I'm outside of outer class trying to access say public static nested class, I'm gonna have to fully qualify the name with outer class. All right, so let's call this static nested class gets new outer class dot static nested class. And that's pretty much it. That's all we need for our little demo here. Let's run it. And here I see hello from static nested class constructor. And we can see that our static field is 0, just like it was initialized to. And we see 0 up here. Just note that I commented all of this stuff out here. Static field is initialized to 0, and it's still 0 when we call it or when we access it from inside our static nested class. All right, great. Now things are going to start getting just a little bit more complicated. All right. I'm outside of static nested class, but I'm still inside of outer class. And here I'm going to do an inner class. Okay, so inner class, public class, inner class. Note that I don't have the static keyword here. This is not a static class. It's non-static, right? That's our definition of inner. All right, in here, I'm gonna go ahead and take a few notes just like I did before. So inner classes are associated with an instance of the enclosing class. So I am going to need an outer class object in order to do anything with inner class. And I'll put here, inner classes can access static and non-static members of the enclosing class. All right, I'm going to have an instance level field, a non-static field, inside my inner class to show you essentially how non-static classes work. All right, so I'm going to call this instance field. Okay, note I also have an instance field up here. This one belongs to outer class. This one belongs to inner class. I am purposely naming them the same to show you a fairly comprehensive demo. All right, time for a constructor. So I'm going to initialize my instance field to just some radically different number, let's say 100. And I'm going to print out hello from inner class constructor in the same fashion that I did for my 2 previous constructors. All right, we're gonna come back to this, but let's run it for now. All right, so here I did not need an instance of outer class in order to create a static nested class object. Okay, I do need an instance of outer class in order to create an instance of inner class because inner class is associated with an instance of outer class. Remember I said things were gonna get kind of crazy. All right, so here we go. Outer class dot inner class is the type of our inner class. And it's tempting to just start to write new, but we can't write new yet because we have to invoke the constructor of our inner class via an instance of outer class. So we're going to use outer class the instance dot new inner class. Okay, this looks crazy weird, but if you think about it, it makes sense, right? In order to access inner class, which is non-static, I need to have an instance of outer class. When I have that instance, I can essentially invoke the constructor for the inner class via the instance because the constructor is part of a non-static class. All right, think about it later. It'll come to you. It'll make a little bit more sense. It looks crazy right now. We've never seen a dot in front of new, but it makes sense because this is non-static. All right, so let's run this. And we should see our hello from inner class constructor. All right, great. Now let's start playing around with the craziness that is our instance fields. And we'll also do our static fields. Those are not as crazy. All right, so let's do that first. Let's prove a little point that we can access static field of outer class from a non-static context. So if I just start typing static field, that's fine. Let's put a little label on this because it's going to start getting crazy. Static field. Okay, great. I run it. Static field should still be 0. We haven't updated it. Okay, this is the same static field that's shared amongst all outer class instances. All right, now let's print out instance field. I want to put a label on it. I think it helps. Okay, so this instance field is going to resolve to the more local scope, which is instance field of inner class, not instance field of outer class. Okay, I could also do this dot instance field. This is going to refer to the same instance field because this refers to this instance of inner class. Let's type that. And if I wanted to refer to the instance of outer class that this instance of inner class belongs to or is associated with, then I would have to do outer class dot this. Outer class dot this refers to this instance of outer class that this instance of inner class belongs to or is a member of. All right, so let's do that. Let's do outer, I think I have a good label for this. Outer classes instance field is outer class dot this dot instance field. All right, so that we initialized to be 1. Okay, so here's inner classes instance field 100, makes sense right here. And here's outer classes instance field, which is 1, makes sense right here. Okay, great. That was crazy. You're doing a great job. All right, next. I'm going to be outside of inner class, but still inside outer class. Number 3. Next, we're working on local classes. So to do this, we need a method, right? We need an instance method. All right, so I'm gonna head over to, actually, let's define it real quick here. So public void instance method. Okay, I'm gonna head over real quick and call this instance method. Then we should be good to go. Outer class dot instance method. All right, so I'm gonna be working inside of instance method for the rest of this video because for our remaining 2 right here, types of nested classes, they're both local, which means they're defined inside a method. So I'm gonna define them inside of instance method. All right, so I'm inside of instance method and I'm going to define number 3. Local class. So I'm not going to make this public. So class, local class. Okay. I can have fields here if I want. Let's do a constructor, public local class. Hello from local class constructor. Okay, I want to prove a little point here. If I run this, am I going to see hello from local class constructor or not? I'm actually not going to see it because we've just defined the class. We haven't actually made a local class object. So let's do that next. Okay, the syntax for this, no different than you're used to. Local class gets new local class. Great. So far, so good. I run it, and now I'm going to see hello from local class because I'm actually invoking the constructor. So that's here. Okay, so far, so good. Another new thing. So local classes can access the local variables of the enclosing method. My spelling is getting much worse. Okay, so here's my enclosing method, right? I could declare a variable here. Let's say I declare a variable called local variable, just something radically different. And let's say I set it to 500, and I'm gonna come into, let's say, my constructor for local class, and I'm gonna try and access this local variable of my enclosing method. Okay, this is gonna work just fine, but let me show you something that might be a little confusing. Let's say somewhere either before or after my class definition, doesn't matter. Let's say I decide I'm gonna reassign local var to 999. That broke my code. Why did that break my code? It broke my code because local class, okay, any code in local class can access local variables of the enclosing method only if those local variables are something called final or effectively final. In fact, if I hover over this error, IntelliJ is going to tell me something different. Variable local var is accessed from within inner class. Needs to be final or effectively final. Okay, so final we know means constant, right? So I could fix this by removing this and slapping a final on it so that I never change the value of local var. Or I could not put this on here, and this is effectively final because nowhere in my code am I changing its value. Okay, so this is effectively final. I'm not changing its value anywhere. Best practice is to actually slap that final on there so that you get a compiler error if you try to change it, not a compiler error down here when you try and access it. Okay, so that's a good lesson to learn because you'll frequently see final on these variables that don't look final, and you're like, oh, why is that the case? Well, it'd probably be good practice if I rename this in macro case to follow constant convention, but I'll leave this as is for now. Okay, so this looks good. The last thing to demo here is, since we're in an inner class, this is non-static, it's associated with an instance of outer class, we can access both the static and the non-static fields or members of the enclosing class. So let's print out instance field, and there's instance field. We can access this in outer class, no problem. And there's that one. Remember, that one's from right here. Okay, awesome. We are now ready to do our last nested class type. Wow, this has been quite the journey, right? So now it's time for the anonymous class. Okay, an anonymous class is just like a local class, same rules apply, except strangely, this anonymous class doesn't have a name, okay? And there's a few reasons why you might do this. Let's say you're only going to use it in this one spot in the code. Maybe it's pretty short. Maybe all it does is implement an interface or, subclass a really simple type or whatnot, and you just want your code to be shorter. It doesn't need to be comprehensive like this. You're not going to use it elsewhere. You're just going to use it right here. Okay, so let's go through an example of an anonymous class. All right, so let's take a few notes first. All right, we need the name of an interface to implement or a class to extend in order to create an anonymous class. Okay, so we know that every class inherits either directly or indirectly from object. So if we wanted to just make, a new generic class, let's say, then the name we would use in place of the new name of the class would be the name of its superclass, which would be object. Okay, but we're not going to name this new subclass of object we're creating. Okay, and this works with interfaces as well. So for a simple example, let's extend object. All right, so I'm going to have a reference to an object called my anonymous object. I'll say my anonymous class object to be very specific. Okay, this doesn't look strange yet, right? I could make a new object just like this. This is just a generic object. Nothing's new here, okay? But now let's say I want to add some custom functionality to a subtype or subclass of object, okay? I could go through and use the class keyword, make something that looks like this, right? This implicitly extends or inherits from object, or I can use an anonymous class, okay? So to do this, I'm going to put in my class definition in curly braces without a name right after I specify my new object, okay? I know this looks a little strange. And so what we can do in here is override methods, right? These could be methods that we inherit from this type. These could be methods that are in an interface if we're choosing to implement an interface instead of inherit from a class. So here I can override any methods that I inherit from object. And a nice little keyboard shortcut is Control-O to see all these. Okay, you don't need to do this, but here's everything that I'm inheriting from object in my anonymous class. This is a full-blown class. It just doesn't have a name. I can't refer to it by name later in the code. All right, so let's do our favorite toString. All right, and in here, I don't really care what I'm gonna do. I'll just return hello, my favorite word. Actually, fun is my favorite word. This is my second favorite word. All right, so now I have this object, right? There's no constructor, right? All I'm doing is overriding methods. I'm gonna use the default constructor that I get from Java for free, right? Default value constructor. And I'm going to use my anonymous class object, right? So I'm going to print out my anonymous class object, which is going to implicitly invoke the toString on the type of my anonymous class object, which is a nameless class that inherits from object. And there we have hello. Whew, that was a lot. There are 4 working examples for the different nested classes in Java. Some of them seem fairly straightforward, like, for example, 1 and 2, a static and non-static class, or nested class. You might use these, if this class, the nested class is only going to be used by this outer class. It's a nice way to keep your code close together if it's going to be used together. And then with the local ones, these are most commonly used for event listeners in event-driven programming. So think about, callbacks and graphical user interfaces, and how if, say you have a button and someone presses on the button, you want to have a method that's essentially called back, it's invoked. That's a case where you really only need to, conform to, say, an action listener or an event listener interface. So real quickly, write in the code where you register the callback, you define the callback, and you have to define the callback by overriding a method in an interface. So that's where you see local classes used quite frequently. If you've done any, Android app development or any Swing development, you'll see these quite a bit. All right, well, congratulations on making it through a very, very tough subject. I encourage you to watch this video again. There's a lot going on here, a lot to unpack, but you did a great job making it through to the end. So thanks for watching, and let me know if you have any questions. You can put them in the comments. Thank you.